Good morning, everybody. This video, I'm going to take some time and show you how to work through the problems on the assignment. It's called Power and Energy Dissipated by a Resistor. There were a lot of mistakes made, and so I just want to take some time here this morning and make sure that you have the correct information. I know for a lot of you, if not all of you, I put the information in there from another source, but just want to go over things one more time with you here. So, first of all, you have two equations plus a few others. Now, these two equations here, you have P equals V squared divided by R. So the power is equal to the voltage squared divided by R. And you have another equation called P equals I squared times R. P equals current squared times R times resistance. Now, the thing is, you want to use one of these two formulas, all right, either this one or this one, depending on what is given in the problem. And these equations, again, one or the other, they're used when you read the problem and it mentions or talks about that the power is dissipated by the resistor. If it doesn't say anything about power being dissipated by a resistor, you don't use either of those equations. In all likelihood, you're going to use the basic power equation, P equals I times V. Power is current times voltage. So for number one, so a heater has resistance of 9 ohms operating on 120 volts, and, so on and so forth, whatever else the problem might happen to say. So in the name of time, I'm not going to read these problems to you because you have the information. So you know the resistance and you know the voltage. So you're going to use this equation. All right, so we square the voltage, divide by 9, you get 1600. That's my power. Now, the second question is, what is the power dissipated? Okay, what is the total amount of thermal energy that flows in 30 seconds? Use this equation here, E equals P times T. 1600 times 30. The time is given. This 1600, of course, is from up here. So you do 1600 times 30, you get 48,000 joules. All right, that's the energy that flows in 30 seconds. Now, you're also asked to convert this to kilojoules. All you do is take the energy here divided by 1,000. All right, so 48 divided by 1,000. I'm sorry, 48,000 divided by 1,000 is 48 kilojoules. All right, kilojoules. Number two, same idea. You have the resistance and you have the voltage. So basically, you do the same process. Again, you have your power, your energy, thermal energy in joules, thermal energy in kilojoules. All right. Now, for problem number 3, you're not going to use either of these equations because the problem reads, an electric space heater draws 13 amps from a 120 volt source. How much power is used? It says nothing about the power being dissipated by a resistor. So again, these two equations are out for number 3. Use this formula here, P equals I times V. You know the current, you know the voltage, multiply the 2, you're done. 1,560 watts. Now, moving on to number 4. What I saw were a lot of students were doing, they were just multiplying numbers together, not really like paying attention to what formula it was that they were in fact using. On the test, you're going to see both of these formulas with a whole slew of other ones. You need to be able to, when these types of problems, when it talks about the power that is dissipated by a resistor, you need to be able to figure out and ask yourself, all right, do I use this formula here where I square the current and multiply by the resistance, or do I use the power formula where I'm squaring the voltage and dividing by resistance? Again, it depends on what's provided for you. In number 4 here on that worksheet, 12 ohms and 15 amps. We're talking about a heater. I think it's what I talked about for most of them. So square 15, since that's the current, 15 squared times 12, 2,700 watts. All right, the energy formula, because you're always going to use the energy formula. So again, one of these two equations here, then you use the energy formula every time. All right, E equals P times T, 2,700 times 41 is 110,700 joules. Divide that by 1,000, 110.7 kilojoules. Number 5, you are using the same thing as number 4. Why? Because you know the resistance and you know the current. So instead of 15, we're doing 13. Just change the numbers around a little bit here. So tell you what, I'm going to slide this over. There we go. So you got 13 times 10, and you get 1,690. So 13 squared, I'm sorry. 13 squared is 169 times 10, 1,690 watts. Then here's your energy equation again. Here's this 1,690 times the time, 41 seconds. And you get that. Then divide it to get 69.29 kilojoules. Now, number 6. Going to bring this over a little bit so you get to stare at my bright orange shirt, perhaps. Number 6. In number 6, we know the resistance and we know the current. So again, which of these two equations are you going to use? It's this one, because you know the current, but you don't. There's no voltage given, so this one's out. So you use this one, and we know the current's 8 and the resistance is 7. So 8 squared times 7, 64 times 7 is 448. Who doesn't know that off the top of their head, right? And then go ahead and use the energy equation, 448 times 11. And 11 seconds, of course, is the time's always provided. And you get 4,928 joules. Divide it, you get 4.29 kilojoules. Number 7 says nothing about the power being dissipated by a resistor. We just want to know the current that it takes to operate a dryer, I think, clothes dryer. So again, P equals I times V. So we know the power is 4,100 watts. We don't know the current. We do know the voltage is 220. So we're going to just do some basic algebra here. 4,100 divided by 220, 18.63 ohms. Now, numbers 8 and 9 are on a separate video that I made where I basically walked you through each and every part of 8 and 9 because let's just say that we ran into some trouble with those as well. So I do hope that you take the time and check out these videos because it's only helping you. We'll have the test a week or two after spring break. I don't know if I have that date set up just yet, but you'll see it posted and it'll be in Edulastic just like all the other tests have been. So if you have any questions, let me know. And know that over spring break, well, maybe some of you have seen it already, I posted one assignment, and it's due on Tuesday, April 6th. Tuesday, April 6th. Okay? So basically, you got like all kinds of time to do it. But I'm not saying work over spring break because, if you don't want to, you're traveling, whatever, I get it. Also, don't forget about the technical reading. You've seen videos on that. We're under a month, 3 weeks from tomorrow, so make sure we're taking care of that as well and get those things turned in. If you want the extra credit deadline, I need it by Friday, April 9th. So, as always, if you have questions, let me know, and I'll be glad to give you a hand.